All right, we're going to do problem number 3 and number 4 from your Algebra Chapter 3 self-test. Number 3 says we have 101 equals 13f minus 2 times the quantity 4 plus 3f. Our goal here is to solve for f, and what we want to do here first is get rid of these parentheses. And since we can't do 4 plus 3f because they're not like terms, we're going to distribute this negative 2. So we're going to do negative 2 times 4, and then negative 2 times a positive 3f. And when we do that distribution, we get the 101 still here. The 13f is still here. This negative 2 times 4 becomes a negative 8. And negative 2 times positive 3f becomes negative 6f. So that's where the 8 and the minus 8 and the minus 6f comes from, is from that distribution of negative 2. Now we have like terms. The like terms that we have here are 13f and negative 6f. So we have 13f minus 6f, and 13f minus 6f is 7f. So we still have the 101 on the left side of the equation. The 7f comes from 13f minus 6f, which leaves us with 7f, and then minus 8 because nothing happened with that. Now we have a basic two-step equation to solve. Our goal is to solve for f. There's no more like terms here. So now we want to eliminate everything from the right-hand side of the equation except for the f. And the first thing we're going to take care of is this minus 8. And the opposite of minus 8 is plus 8. And what we do to one side of the equation, we do to the other side of the equation. So add 8 on the left or the right-hand side. We're going to add 8 on the left-hand side. And when we do that, what we get is 7f, because the 8's are gone, the 7f stays. And this 109 comes from 101 plus 8, which is 109. And our last step now, since f is not alone and we're multiplying it by 7, we want to divide by 7. So we're going to divide both sides by 7, and the result there is 109 over 7 is what f is equal to. Leave it as a fraction. If you try to do 109 divided by 7, it's going to be a decimal, and we'll always want to start leaving our answers as fractions unless we are otherwise instructed to do so, to change them to a decimal or a mixed number, or if the context allows us to, or is asking us to change it to a decimal or mixed number. Leave it as a fraction unless that stuff is happening. So our answer here is 109 over 7, and that's reduced as far as it can go. So 109 over 7 would be your answer for F. Number 4, same kind of idea here. We have x minus 4 inside the parentheses. We can't do x minus 4 because they're not like terms, so we're going to distribute that 3. So we have 3x minus 12. The 3x comes from 3 times x. The 12 comes from 3 times 4. And then we have greater than or equal to 12. And the fact that this is an inequality doesn't have any effect whatsoever on how we're going to solve for the variable x. No issues with that at all. It's just the same process with one small caveat, which we will see a little bit later. So we have 3x minus 12 is greater than or equal to 12. We want to solve for x, which is on the left-hand side. We want to get rid of this minus 12, and the opposite of minus 12 is plus 12. So we're going to add 12 to both sides to get rid of this negative 12 or minus 12, which will make this 0, and then we have 12 plus 12 on the right-hand side. So that becomes 3x is greater than or equal to 24. One more step here, because we have an x times 3. The opposite of x times 3 is divide by 3. So we're going to divide both sides by 3, and as a result of that, we get just the x on the left-hand side, and on the right-hand side, we get 24 divided by 3, which is 8. So our answer, or our solutions to this inequality, is x is greater than or equal to 8. And what this means is we can pick any number we want to, as long as that number x is greater than or equal to 8. And if we plug that back into our original inequality, we'll get a true statement. If you pick x to be 10 and you plug it in here, you're going to get a true statement. If you pick x to be 8 even, you'll get a true statement. But if you pick anything that's less than 8, this statement will not come out true. And that is what the solution to this inequality means here.